Both of these integrals are improper integrals, and you can see why very easily if you look at the limits of integration. We have an infinity as the upper limit of integration for both. And if you look at the graphs for 1 over x, if you start integrating at 1 and you start finding the area out towards infinity, you can see that you're headed towards an asymptote at y equals 0. And the same is true for e to the negative x. If you start at 1 and you start integrating out towards infinity, you're headed towards an asymptote. So both of these problems will be done with limits. So the way we approach this is we look at what exactly is making it improper. In this case, it's the fact that it's headed towards infinity, and that's where I'm going to put my limit. So I'm going to change this to the limit as c approaches infinity of the integral from 1 to c of 1 over x dx. And then that becomes the limit as c approaches infinity. The antiderivative of 1 over x is the natural log of x, and that is from 1 to c. So that will be equal to the limit as c approaches infinity of the natural log of c minus the natural log of 1. Now, as we look at this and we evaluate the limit, the natural log of infinity is infinity, and just a reminder what the natural log graph looks like. As you head out towards the right, it continuously increases. So this would be infinity minus, and then the natural log of 1 is 0. So this integral would equal infinity. So if you look at this, starting at 1 and headed towards infinity, you're adding up area forever and ever and ever and ever, and it actually gives you an area of infinity. In other words, it's not bound, it diverges. So for this problem, we have the same issue. We have infinity as the upper limit of integration, so that's where I'm going to be working with my limit. So I'm going to say that this is equivalent to the limit as c approaches infinity, the integral from 1 to c of e to the negative x dx. So what I'll do next is find the antiderivative of e to the negative x, and this is u substitution. I have a u equals negative x, a du equals a negative 1 dx. So this right here is a negative e to the u du because I have a positive dx here and I have a negative dx there. So this will equal the limit as c approaches infinity of a negative e to the negative x from 1 to c. Now this negative x, the negative exponent, actually just moves this to the denominator. So what this is actually equivalent to is the limit as c approaches infinity, and I'm going to rewrite this as a negative 1 over e to the x from 1 to c. Now when I actually put my limits of integration in, this becomes the limit as c approaches infinity of negative 1 over e to the c minus a negative 1, so plus 1 over e to the first. So when I evaluate my limit, c is approaching infinity, so e to the c, is approaching e to the infinity, which is infinity. So I have a negative 1 over something really, really huge, and this goes to 0. And then I have 1 over e to the first, which is just 1 over e. So this one actually has an area you can found. It's not unbounded, it's not diverging. It actually approaches a number, whereas this one approaches infinity.